Alright, I have two switches and I gotta try to fix these things quickly because I'm running behind on many things and I need to get these fixed. So I paid $100 for them, and yeah, so one of them I know based on looking in the port when I initially got them has a bad HDMI or a USB port. Let's see here. Yeah, this is the one I think has a bad HDMI port. This one does not have, oh, let me switch back over. This one does not have a bad HDMI port. So yeah, it gets up to like a 300 and something milliamps and does nothing else. So we'll look at this one first. So let's disassemble. So no chart or no shorts around anything, but it's still only setting at 471. But then again, this battery may be horribly dead. Let's check for voltage. So we got 4 volts there. We're sitting at 4.1. Is it going to go up or? Alright, man, so I've been working on this thing for days now. And so this is so I had 2 originally. And this one just needed the USB port changed. It worked fine other than the USB port. So, and I don't want to just randomly change parts for no reason. So my goal was to figure out how this thing worked. You know what I'm saying? That was the goal. Put my multimeter back where it goes. But so anyhow, so let's have a conversation real quick, right? So we're gonna plug in the battery for we plugged in the battery to our Nintendo Switch, right? So we know that our battery is charged and it's putting out 4.18 volts, yeah? So that's what it's supposed to do. So if I come over here to this capacitor down at the bottom, I'm reading 3.92 volts. If I come to this capacitor, I get 4.18 volts. And then if I come to this inductor right here, I get 4.17 volts. So we know that the battery is supplying voltage to the BQ chip. The BQ chip is doing its job and it's switching that voltage to this big inductor. And this big inductor, the voltage here is known as VSys, right? So that's the system voltage. So we know all of that. We know the BQ is working. The M92 is irrelevant for what we're trying to do here, because the M92, it has voltage at various places. Like down here at the bottom, it'll have 1.8 volts. Up here on these big caps right here, it'll have, and we can look at that later, but the system's not turned on yet, so we don't have those voltages at the M92 chip. Now if we were to plug in our USB cable, then the system automatically tries to turn on. then we would start getting voltages around the M92 chip. But anyhow, we know the M92 chip is fine. Our issue is that we're stuck at 470 milliamps. So the next thing is this chip right here, which is the 77812, I think, 77812 Max 77812 chip, and it's a voltage regulator, and there are four inductors that surround this chip, and those four inductors, once the system's turned on, the chip will produce voltage on those inductors. So let's look under the microscope so we can see what we're doing. And I will switch over to the microscope. So in an off condition, if I measure around these inductors, notice I get nothing. I get no voltage at all, right? But what I do have here is I have battery voltage, or the VSys that is coming out of that BQ. So we know we have VSys into this chip, but the console's off, so we don't have any voltage on those inductors. So let's go back to the camera real quick. So if I were to touch with the tweezers the first two pins where you plug in your ribbon cable for the on-off switch, those first two pins will give me, that will cut the system on. So let's switch back to the whatever this thing's called, the microscope. Let's flip this up, and let's just stick our tweezers right here. Now the system's on. So let's go back to this chip where we were originally at, and let's see what's changed. So now that the system is on, if I check on this inductor, I get 0.6 volts, indicating that it's on. On this inductor, I get nothing. On this inductor, I get nothing. And on this inductor, I get nothing. So I also get 1.8 volts at the bottom of this pull-up resistor right here. Okay? So now the question is, well, where does that 1.8 volts come? So we know we have VSys coming into this chip. We know we have 1.8 volts coming into this chip. So now let's figure out where does that 1.8 volts come from. So let's flip the board over, and then let's look in this area right here. This is the other Max IC. So the Max IC produces quite a few voltage drops. So if I go one probe on ground, so if I come to this first inductor, we get 1.8 volts. So that 1.8 volts that is generated by this Max IC is felt on this inductor and then felt on the other side of the board to the other Max chip. And that essentially, I would assume, is one of the enable signals that tells that Max IC to turn on. On this, we're supposed to have 1.3 volts, and notice we have nothing. On this, we're supposed to have 1 volt, so that's good. That's good, they're tied together. This other inductor is 1.1 volt. So we are missing, for this broken console, we are missing our 1.3 volts that we're supposed to feel at this inductor. Okay, so now let's go under a working console. This is the other console I had sitting here. So same thing. We got battery plugged in, and if we come to here, we should have VSys, and we do. And this is also a fully charged battery. Let me go ahead and turn this or unplug this other. So now if we come over here, and we measure voltage on this inductor, we have nothing. On this one, oh, I'm not even, You guys can't even see what I'm doing. On this one, we have nothing. So let's reach up and let's turn this console on. Since I have the ribbon cable plugged in, I'm just going to turn the console on. Now let's go back and check those voltages. So remember, on the broken console we have 0.6 volts here, and so on this console we also have 0.6 volts. Now on this inductor we get 0.6 volts. On this inductor we get 0.6 volts. On this inductor we get 0.6 volts. And on the other side we would obviously be getting the 1.3, but we are not. So I'm going to go ahead and turn this console off by unplugging the battery. So let's get our console. And so there's one other voltage that we need to look at, and that is the 3.3 volts that you will find when the console is on. You will find it by the M92 chip. You should find it somewhere in here. I think like maybe right here, maybe. So let's turn the console back on by again shorting out the first two pins with a pair of tweezers. Now the console's on. So let's see if we have voltage over there by the M92. Remember, the M92 I measured, obviously when you have it plugged in you're going to have your voltage from your USB coming into the chip, but you're also going to have your 1.3 volts coming, or your 3.3 volts, excuse me, coming from somewhere else on the board. The M92 does not generate that 3.3. If I come to this capacitor right here, we have 1.8 volts. So we know that our 3.3 is good. Let me show you where it's originated. The 3.3 volts is originated at this little chip above your audio IC. So if I come here and I measure, somewhere in here I should get 3.3. I don't know exactly where. That's the input voltage, so it must be on these output caps. So there we go. So this little chip is generating 3.3 volts. So we're missing two voltages. We are missing 1.3 volts here. Let me see if I can move this in a little bit. We're missing the 1.3 volts here, and on the other side of the board we are missing 0.6 volts on these three inductors. This inductor gives us our 0.6 volts, but the other ones don't. Now if we take a resistance, let's measure resistance. So I'll put my multimeter to resistance mode. So if I go from ground to this inductor, I get 29 ohms. Now if I do that same thing on this inductor, I get 65 ohms. So I'm getting basically twice as much resistance on the working board as I am on the non-working board. So let's come over to this inductor and go from ground. So this one is 44 ohms. This one is 1.9 K. You see what I'm saying? So there's, just in terms of resistance on those two max ICs, it's different, but I don't know, and I couldn't find it on the board scan, where it goes from here. I'm assuming there's two power rails for each, two for the CPU and then two for the eMMC. You'll also find that that 0.6 volts along these on a couple of these capacitors down here. Now I don't know exactly which one of these coils that 0.6 volts is coming from, but it's coming from one of them. So So I don't know, I don't have all the information that I need, because I've read online that some people are saying that the 1.3 volts that you're supposed to get here can be affected by things elsewhere on the board, but it seems to me that this chip is generating the 1.3 volts, right? So if I'm not getting 1.3 volts, and if I go from ground to this coil, we're talking kilo ohms of resistance. So it's not like it's shorted, you know, it's not shorted. This inductor is a short, so if my voltage rail is not shorted, and this chip is responsible for creating the 1.35 volts, then wouldn't it be logical to presume that that chip is faulty? I don't know. I'm torn because of, one could also argue that if this chip is responsible for generating 0.6 volts on each one of these inductors, then wouldn't that indicate that that chip's bad? So I'm missing 0.6 volts on 3 of the inductors, and I'm missing 1.3 volts on that inductor. So how are those two things interlinked? So it could be that I replace this chip and I am still missing my 1.35 volts. But I think the only way I'm going to ever get to narrow down the problem is by replacing this chip and seeing what changes. I don't want to just randomly change things, but I don't know that I have a choice if I want to figure out the root cause of the issue. So let's go into the microscope and let's change this chip, or try to. I'm not sure I'm qualified to do this. There's like capacitors. I don't know, man. I don't know. We'll see. All right, let's switch back over to the microscope. Let's hope we don't knock off any capacitors, because this is horribly small. I see other folks doing this, and I'm like, man, you guys are professionals, bro. So I'm going to hit it with a lot of heat so I can get in and get out. Alright, we got it off safely. I'm assuming that's good. I hope I didn't bump it too far and cause shorts. That would suck. Alright. Now, let's plug the battery in and see if I killed the chip or it's on there or what. Pretty sure that chip's dead, as long as it took me to do all of that. See if we get any voltage at all. .8. No way, dude. Did y'all see that? No way. That chip was bad. Now I'm getting my 1.3 volts. Getting my 1 volt. 1 volt. We're in business. Let me let's flip this over. Let's go to the max chip and see if we're getting any voltage now out of. No, we're still not getting any voltage out of that inductor. We're getting 3.9 volts there though. Why are we getting 3.9 volts there? Are we supposed to get 3.9 volts there? What? Oh, we were getting 0.6 volts there. Unless I shorted something, which is possible. Well, let's plug it. You know what? Let's do this. Let's switch back over to the camera. And let's plug in our ammeter and see if anything goes boom. Alright, so we're still stuck on 474 amps. Which tells me that this max IC has to be bad. I'm getting 0.6 volts. And I'm still not getting 0.6 volts there. So we fixed one problem. And now we have another. But just for the sake of being thorough, we are going to put this inside of the case. Let's plug in the USB cable. And let's see if we get so still no battery indicator. Did the resistances change around there since I've changed that other chip? I don't think they did. Yeah, so I think the only thing we can do is to change this chip. I think that's our only option. And I don't have any of those chips. And I'm not altogether certain. I don't know. I don't know what to do. Let's try to get this chip off. Oh, that does not look good. Looks kind of crusty looking. So let's now measure resistance with that chip completely removed. On this coil it was 30 ohms. Yeah, where you can see it on this coil, it was 30 ohms. What is the resistance now? It's bouncing all around. It's actually going down. What about this other coil? Same resistance. That's not good, y'all. That is not good, because if that chip wasn't giving the low resistances, then it has to be something else giving the low resistance. The resistances on the other side were always fine. They're like 18 ohms or something like that. Yeah, so they were both the same on the working board and the broken board. So I don't think this is cleaned all the way. It's not. Oh, my goodness, man. All right. This sucks, man, because I'm pretty sure that something else is causing this to be that way. So I do have this one, this other one right here that I pulled off of the one that had a shorted motherboard. I do have that one that I can put on there. I don't know if it's any good. It's not reballed, but I can try to get it on there the best I can and see if that makes any sort of a difference. I don't think it will, because like I said, these two right here I think feed the processor, and it doesn't seem likely that one processor would have a high resistance in the kilo ohms. But again, I don't know. I don't know the full path of this thing. I think it's on there. Maybe. I don't know. Let's check resistance and see if anything changed. Doing something different. This one probably didn't change. No. It's doing the same thing. So, alright, I think it is safe. Let's plug in our power adapter. Yes, dude, we get 920. Alright. You got no, dude. Don't tell me this thing's gonna work. Let's put it back in the case real quick. Alright, it didn't work. It did not work. It's still, I can't, it's still stuck on that 400 amps, man. I think the CPU's dead, bro. I think that's what the issue is. And there's not a whole lot you can do about that. So I think we'll call it quits on this one. I learned a ton about it. I actually sat down and tried to figure out how all of the voltage is related. So luckily we fixed the 1.3 volt issue that we were having. But I couldn't fix this. This thing had two problems. It had the 1.3. Yeah, that processor's not even getting warm. But we had the 1.3 and the and this right here. So anyhow, y'all be good.